Unit 10, an introduction to calculus with a specific focus on limits. Any well-respected introduction to limits will begin with a discussion of Zeno's paradox. If you're not familiar with Zeno's paradox, Zeno was an ancient Greek philosopher, and he proposed this argument. Now, a paradox is a statement where you could draw two possible valid conclusions that are actually contradictory to each other. And one version of Zeno's paradox asks you to consider a race. Now, Achilles, let's call this guy right here Achilles. Let's say that Achilles is in a race, and he's running to the finish line, and before he can travel the entire distance of the race, he has to first travel half of the distance to the finish line. And then he continues running, but again, before he can reach that finish line, he has to travel half of the remaining distance. Now, the remaining distance being half of the overall race, and half of the half is a fourth, so that would be a fourth of the overall distance. And then once again, before he can finish this race, he still has half of the remaining distance left to travel, and then half of that remaining distance, 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 and so on and so forth. So here's where the paradox lies. Will Achilles ever reach the finish line? Now, one line of reasoning you might be following is to say, well, of course he'll finish the race. If the race is some finite distance, and at no point did I say that it was an infinitely long race, I am not making that claim. This race is exactly 1 unit long. The unit is, of course, completely arbitrary. This could be 1 mile long, it could be 1 meter long, it could be 1 kilometer long, it could be 1 light year long. It does not matter how long this race is. It is exactly 1 race distance long. And since that is a finite distance, yes, of course Achilles will finish the race. But if we use this half distance argument, if he has to travel half the distance of the race first, and then half of that remaining distance, and then half of that remaining distance, and then half of that remaining distance, theoretically, couldn't we continue that half distance forever, infinitely along the course of the race? No matter how far Achilles travels, there will always be another half distance left remaining that he must travel before he reaches the end of the race. Now, the ancient Greeks would have seen this as merely an interesting thought experiment and then not gone that much deeper into it. And for thousands of years, we had no way of reconciling this paradox. Nowadays, modern mathematicians would actually not even consider this a paradox because we've invented a technique in mathematics that actually reconciles this paradox. And that's the concept of the limit. A modern mathematician would look at this sequence of half distances and start adding it up and see what it adds up to. For instance, that first half distance, we'll call it r sub 1 for the first leg of the race. That first half distance, adding up 1/2 on its own, you're going to get just 0.5. Now, if I add the second leg of the race up, 1/2 plus 1/4, now I get 0.75. Adding in the third leg, plus 1/8, I get 0.875. Adding in the 1/16, 0.9375. Adding in 1/32, I get 0.96875. Notice, as I add more and more legs of this race, that total length of the race, in this case r sub 5 is represented by about 0.968, is getting closer and closer to a certain value. It doesn't increase forever. As I increase more and more, as I add more and more legs to the race, the total distance traveled by Achilles gets closer and closer and closer to a particular number, and that number is 1. Even though we're adding an infinite number of fractions, and I'm just arbitrarily stopping here at 1/512, I could keep going, and it's going to tell the same story. The total length of the race just gets closer and closer and closer to 1. And we call that the limiting value. Even though we are adding an infinite number of numbers, there is an overall limiting value to that sum, which of course is called the limit. Now, the way we would notate that is I would just label the entire sum of fractions, 1/2 plus 1/4 plus 1/8, and so on and so forth. I'm just going to label it r sub n, where n represents the total number of legs of the race. And again, I could technically add up an infinite set of fractions. So what I'll do is I'll put a little symbol in front, which represents the limit as n approaches infinity. And again, being the number of legs of the race, They're an infinite set of numbers being added together, and we will use LIM as an abbreviation for the word limit. So that's asking what is the limiting value of this sum of fractions. As the number of fractions increases to infinity, the actual sum is limited by the value 1. It is a common misconception in math that if you do something an infinite number of times, it will give you an infinite result. But as we look at examples like this, one of the biggest hurdles that we have to get over is that it is in fact possible to do something an infinite number of times and get a finite result. If something has a limiting value that it can't go past that particular value, whether or not you can show arithmetically that you in fact reach that value becomes irrelevant. If you can theoretically prove that the limiting value is 1, then we can say that the limit of the sum approaches that value and simply use that as the answer to the question. Now, in this unit, we're going to take a deeper dive into that idea of the limit, and then the limit as a whole is going to serve as one of 3 pillars on which the wonderful world of calculus is built. Now, this doesn't end our introduction. There are actually 3 other videos that I want you to watch instead of me re-recording my own personal take on these concepts. I found 3 particular videos that I actually like and I think do a good job of explaining just the big picture ideas of what we're going to be doing over the next few weeks. So go ahead and jump over to those videos. If you're watching this on YouTube, those videos will be listed in the description below. If you're on my Canvas page, then the other 3 videos will be listed on the Canvas page itself. Once you finish watching these, this one and the other 3 videos, there'll be a short quiz for you to take on MyMathLab. All right, let's get started.